Public air travel is defined by boarding passes, overhead bins, and checked luggage. Yet operating right beneath the floorboards of passenger cabins and out of entirely separate airfields is a massive, highly synchronized commercial network. This system operates on a relentless clock. A single delay ripples across the globe, forcing assembly lines to stall and critical medical shipments to expire. Today, that pressure is illustrated by two extremes: 60 tons of raw industrial steel destined for a mine in Africa, and a $55 million shipment of cancer drugs bound for the United States. Getting them airborne is a high-stakes battle. Every departure is an active negotiation against the laws of physics, fragile chemistry, and the unpredictable forces of nature. The macro challenge begins at East Midlands Airport in the UK. Ground crews are tasked with loading two massive 30-ton rock crushers into the belly of an aircraft. The only plane suited for a load this tall and wide is the Antonov An-124. Originally built as a Soviet military behemoth, it was designed specifically to swallow tanks and missile systems whole. This schematic of the Antonov highlights the precise balance point crews must hit. The operator drives the 30-ton crusher up the ramp by remote control, aiming to position it without unbalancing the aircraft. If that weight shifts too far to the rear, the plane's center of gravity follows. A miscalculation of just a few feet can cause the nose of the plane to pitch up and slam the tail into the tarmac. While the Antonov handles sheer mass, a team in Northern Ireland manages a microscopic battle. They are moving 17,000 glass vials of a breakthrough cancer treatment that must be kept strictly between 2 and 8 degrees Celsius. These vials travel in specialized battery-powered envirotainers. The second these units are unplugged from the grid for loading, a strict countdown begins. If the battery dies, the temperature climbs, and $55 million of medicine is ruined. Defying sheer gravity and protecting fragile chemistry are the first hurdles. Successfully sealing the cargo doors is only the beginning of the vehicle's physical trials. At UPS Worldport in Louisville, Kentucky, the scale of this operation is immense. This automated facility serves as the heartbeat for a global delivery fleet of nearly 250 aircraft. Because heavy cargo planes lack the ability to reverse under their own engine power, every departure depends on a specialized driver to physically push the aircraft away from the gate. This weight comparison illustrates the extreme physics involved. A driver in a 50-ton tractor must generate enough force to overcome the inertia of a fully loaded 450-ton Boeing 747. The only link between these machines is a single red tow bar pinned to the plane's nose gear. A misaligned turn or a sudden jerk can overstress the landing gear, causing mechanical damage that grounds the aircraft immediately. In a synchronized network, one damaged gear traps the plane at the gate. That single delay triggers a chain reaction across the entire fleet, neutralizing all the effort spent loading the cargo. Even when an aircraft is loaded and pushed without a hitch, nature holds the final veto over the departure sequence. The mechanical threat is severe. A single 1-pound gull ingested into a jet engine can instantly shred the internal fan blades, destroying a multi-million-dollar engine in the middle of a takeoff run. Back at East Midlands, wildlife control officers use low-tech methods to clear the path. They patrol the airfield in marked vehicles, using their presence and manual scare tactics to move stubborn flocks away from the active runway. When birds refuse to budge, the tactics escalate. Officers must get tower permission to use high-tech distress calls and explosive flare cartridges to finally clear the tarmac for departure. Ultimately, millions of dollars in engineering and logistics are protected by human vigilance against the local bird population. Once the path is clear, the flights depart. The cancer drugs head to Philadelphia, and the rock crushers begin their journey to Gabon. The global supply chain is often viewed as an automated mechanical monolith. In reality, it is a fragile system held together by a hidden human ecosystem. Every successfully delivered machine or medicine is a quiet, daily triumph of human logistics over the unforgiving laws of nature.